Alright, so problem number 88. In this one you have a truck that has a, does it say what it is? Just a box resting on the bed of the truck that weighs 12 kilograms. And it's sitting 1.8 meters, I don't know if you guys can see that or not, 1.8 meters away from the tail of the truck. And the truck is accelerating from a stop sign with a acceleration of 2.2 meters per second squared. Also, it says that the coefficient of friction for static and kinetic are 0.19 and 0.15 respectively. So the first thing I did is I found the normal force, because you need that for the friction equation, because that's mu times the normal force. So that is 9.81 times 12, because that's gravity times the weight, because force equals mass times gravity, and the normal force is going to be acting opposite. So the normal force comes out to be 117.72 newtons. That's what it is. So then the next thing I did, just to make sure, is I made sure that the box actually did move relative to the truck, because it'd be kind of stupid if you did all the work and it just didn't move anywhere. So really quickly, I calculated out the force of the static friction. That should have been S. Let me go ahead and fix that real quick. So the force of static friction and the force of kinetic friction underneath it. So the force of static friction, you have your normal force, which is the 117.72 that we just got, times your coefficient of friction, which is 0.19, and that equals 22.3668 newtons of static friction. And then force equals mass times acceleration, which means that force divided by mass equals acceleration. So I took this answer that we got here, divided by 12, because that's the mass of the box, and that equals 1.86, which is less than the 2.2, so therefore it is actually accelerating. So now that we know that the box actually moves, I went ahead and did the same thing, but I switched out the coefficient of friction from static to kinetic. So the new force of friction is 17.658 newtons. And then again, I divide that by 12 to get the acceleration, and that comes out to be 1.4715 meters per second squared. Or, if you find the difference between the two, it's 0.7285 meters per second relative to the truck, or away from the truck. Because if the truck is moving 2.2 meters per second to this way, and the box is accelerating this way at 1.4, relative to the truck, which is accelerating faster, it's actually accelerating that way at the 0.7285 meters per second. So, yeah, now that we have that, we can go ahead and figure out what it's actually asking. So in part A, it is asking us, or it doesn't give us part A, it just asks us how much time elapsed before the box falls off the truck. So I use delta x equals v naught t plus 1/2 at squared. In this, we know that v naught equals 0, so that part's 0. Delta x is the distance before it falls off, which is 1.8 meters. And then your acceleration, we just got that right here. That's the relative acceleration. So yeah, so first thing I did is I multiply both sides by 2, and you get 3.6 instead of 1.8 over here, and that gets rid of the 1/2 there. Then you divide everything by your acceleration, the 0.7285, and that gets you t squared. So if you take the square root of 3.6 over 0.7285, you get that the time equals 2.22 seconds. And that is the first part. The second part is it asks you how far does the truck travel in this time. So I use the same equation because it works. Again, your v naught is 0 for the truck because it starts stopped. And then your acceleration this time is going to be the 2.2 meters per second that the truck is moving. So you get 1/2 2.2, or 1.1 if you can do, 2 divided by 2 easily, times your time, your 2.22 squared, and if you just put that into a calculator, you get 5.436 meters.